Today we're going to look at simulation, and we're going to be doing that within Autodesk Inventor. Before I begin, this is not an in-depth instructional video about how to do proper simulation within Inventor. This is simply a short clip to allow students of higher graphic communication to understand how to use the simulation software that's built into Inventor. So please, if you're looking for something in-depth and something which is to industry standards, then this is not really the video for you. What I've done here is create a long square section bar, and what I'm going to attempt to do is simulate a load placed in the center and see what kind of information I can get from the simulation software within Inventor. So I'm going to close the simulation part of it just now, and this would be the normal screen once we had made a part. Along the top we've got all the usual commands which you're very familiar with, and along at the end we've got one that you haven't used before, which is called stress analysis. One of the first things we have to make sure that we have in place before we begin our stress analysis is that we have given this part a material. Now remember, the material is this box at the top. Anything in this box is simply an appearance about how the part looks, nothing to do with its physical properties or characteristics. We have to make sure that we have given the part that we're going to conduct an analysis on a correct material, and in this case I've simply chosen steel from the drop down list. Once I've done that, I can go to stress analysis. Most of the buttons will grey out until we create a study. A box comes up with lots of information which we don't have to worry too much about. I'm simply going to select OK, which is enough for our purposes, and the buttons now make themselves available. What I would like to do is fix the bar at this end and at this end, and then place a load on the center and see how much it deflects and how much stress is placed on the beam once it has a load in the center of it. So to start with, I need to put in some constraints. Constraints are just anchor points. So I'm going to tell the analysis model where I would like this beam to be held, and it's a fixed point. First one I'm going to choose is this bottom edge here. Then I'm going to rotate around and choose the bottom edge here, and then apply those. So I have my two fixed constraints in place. Next I'm going to apply a force to it. The force I'm going to apply is 1000 newtons, and I'm going to simply select the top face. The arrow tells me the direction of the load. If I wanted to, I could make the load come up the way, but in this case I want it to be a load down, and I'm going to apply that and select cancel. I can't really see where the load is on it, but there are some little icons up here that I can click on, and that will bring back the indicator for me. So there's my load, the yellow arrow pointing down the way. I'm now going to simulate and apply that load and see what it does. Inventor does all the calculations and all the analysis, and it then gives me an indication of where the stresses are greatest. We have what's called the von Mises stress here, which is a colour indication telling us how much stress the material is under. And if I look down to this bottom corner, I can see in red, going over to my scale, that's the greatest point of stress within this bar. There are some other indicators I can get. I can look at the displacement, and at this point here is where the greatest displacement takes place. And if I go up to this little icon here and click on it, it will tell me that the maximum deflection, that means how much that bar would move, is 0.4 of a millimeter. So quite a small displacement. That's about all the information I would need, so I can now click Finish Analysis. And that was a simple analysis done on just a square section beam. I'm now going to take us back to the pogo stick that we made a few months ago back in Hire, and we can see here the steps that the person would stand on. So this is a kind of real life simulation I'm going to do here. I'm going to look at just that part in isolation, and once again I've given this a material which is mild steel, and I've coloured it red just so that it's easy to see. So what I'd like to do here is carry out a stress analysis to see how well these foot pegs would cope with the weight of someone using this. And for the purposes of this test, I'm going to assume that the person has got a mass of, we'll say 400 newtons, and that 200 newtons would go on that foot peg, and that 200 newtons would go on that foot peg. Now once again, if you're watching this and you are a mechanical engineer or someone that's familiar with stress analysis, you'll know that I'm making an awful lot of assumptions here. This is a pogo stick which has a spring at the bottom, so the full force would probably not be applied quite that way. However, for our purposes, that's what I'm going to use. I'll begin my stress analysis. I've double checked it, I have a material assigned. If I don't have a material assigned, it won't work, so I have to make sure that's in place. I'll create a study. Once again, I'll just accept anything that's in these boxes, and I'm going to apply my constraint. And in this case, I'm going to flip the pogo stick round, and I'm going to constrain on that circle at the bottom. Back to my home view. So the pogo stick is now fixed at that point. Now in real life it would have a spring, so the pogo stick body would move up and down, but for the purpose of the analysis, I'm going to say that the body is now in a fixed position. The next thing I have to do is apply my force to each of those 2 foot pegs. And I'm going to put 200 newtons, and I'm going to apply it to that surface and that surface there, and I will apply it and cancel. So I have my material, I have my constraint, I have my forces, and I'm now ready to simulate. Run the simulation, let Inventor do all the mathematics for us, and we should now be able to determine the kind of stress and the kind of deflection that's going to occur on these foot pegs whenever someone uses the pogo stick. As I said, in real life it's got a spring at the bottom of it which will greatly affect the forces and the time duration of the forces and a lot of other things that go on within this pogo stick. And here I have my von Mises indicator showing where the stress is. And if I look down at the bottom, I can see that the area of greatest stress is just here where the foot pegs join the body, and that's where you would expect it to be. If your foot is on here pushing down, it's going to tend to bend this part here. We'll just look at displacement, and we'll see that the greatest displacement is at the end, which again makes kind of sense. That's what we would expect it to be. And we can once again look on here and see what that deflection would be. The deflection would be somewhere just over ½ millimeter. So it would be a fairly rigid foot pedal. Once again, I'll repeat, if this is a video you're watching hoping to get some in-depth instruction or education on how to conduct stress analysis in real life, this is not the film for you. This is simply to allow pupils of advanced higher graphics to understand how to use the simulation within Inventor. Last thing we would do is finish the analysis.